Today's lesson is 5.6, inverse of a function, and we're going to just do part of it today. So the first thing we're going to try is they're telling us f of x equals 3x minus 5. We want to solve y equals f of x for x. So basically they're telling us to replace this f of x with y. So it's really y equals 3x minus 5. And now we want to solve for x. We want to get x by itself. So the first thing I would do is I would get rid of the minus 5. So I would add 5 to both sides. So now y plus 5 equals 3x. And to ultimately get x alone, I would divide by 3. So I'm going to divide this side by 3 and this entire side by 3. So I could either write it as y plus 5 over 3 equals x, and I'm okay with that right now. Or I could really go one step further and put both of them over 3 separately, in which case it would be y over 3 plus 5 over 3 equals x. I'm not as into that because I don't like that 5 over 3. It's not going to help me really. The only real reason I would do that is if I was really trying to get my function where my variable was separate from the other number in case I had to graph it or something like that. So now we're going to find the input when the output is negative 11. And normally, input was the x, output was the y. So we want to find the x when the y is negative 11. So I could substitute negative 11 into this equation for the y. So now I have negative 11 plus 5 over 3 equals x. So negative 11 plus 5 is really negative 6. So now I have negative 6 over 3 equals x, and if I reduce that, x equals negative 2. So the input is negative 2 when the output is negative 11. You're going to try the next one, hit pause, and when you're ready, come back. Okay, so for A, we would have had x equals y plus 2. You could have had y plus 2 equals x. That's the same thing. And the input x is 4 when the output is 2. So now we're going to talk about inverse functions. And inverse functions are functions that undo each other. Inverse functions interchange the input and output, which means that they interchange the domain and range. So if your original function was 2x plus 3, your input of negative 2, negative 1, 0, 1, 2 would have given you negative 1, 1, 3, 5, 7. The inverse of that function is x minus 3 over 2. And now my domain, or my x values, are negative 1, 1, 3, 5, 7. And if you notice, these numbers here are the exact same numbers that were here for the y's. So the x's and y's completely switch. Right? Same thing for the x's here. These x's became these y's. Also, the graph of an inverse function is a reflection of the graph of the original function through the line y equals x. So that's this dashed line right here. That's the line y equals x. And if my original function was f, g is my inverse. They are equally distant from the line on either side. Right? It is a true reflection. To find the inverse of a function algebraically, what we're going to do is we're going to switch the letters x and y and then solve for y. So we actually just take the original function, change the letters, swap them, and then solve for y. So we're going to find the inverse of f of x equals 2x plus 8. So I'm going to first change the f of x into a y, just like we did in the first example. So we have y equals 2x plus 8. And now I'm going to switch the letters x and y. So I'm going to rewrite it as x equals 2y plus 8. And now I'm going to solve for y. So I'm going to get rid of this plus 8 first. I'm going to minus 8 from both sides. So now x minus 8 equals 2y. I know I want to get y alone, so I'm going to divide by 2. I'm going to divide this whole side by 2. And now this is where I probably would separate it, especially because those go in evenly. So I'm going to separate it to be 1x over 2 minus 8 over 2. I'm just going to do this in 2 steps, equals y. And this I can rewrite as 1/2 x. This I can write as minus 4 equals y. And that is the inverse of my original function. So you go ahead and try this one. We want to find the inverse of f of x equals 1/3 x minus 2. Pause and unpause when you're ready. So we should have had as a final answer y equals 3x plus 6. Make sure you distribute that 3 to everything once you multiply both sides by 3. The inverse of a linear function is always another linear function, but nonlinear functions can also have inverses, though they may not always be classified as functions. So in order for a nonlinear function and its inverse to both be considered functions, the domain would have to be restricted. There is a way to tell graphically if its inverse will be a function or not. So just like telling if something was a function originally, we would do the vertical line test. You could do the horizontal line test. But we're just going to focus right now on finding the inverse, not necessarily using the graph. So we're going to find the inverse of f of x equals x squared minus 2. Right? We don't care whether or not the inverse is a function or not. We're just going to find its inverse. So first, again, I'm going to rewrite it with a y. So we have y equals x squared minus 2. I'm going to switch the letters. So now it's x equals y squared minus 2. And my goal is to get y completely alone. So I'm going to start by adding 2 to both sides. So now x plus 2 is equal to y squared. And now to get y squared to be just y, I know I would have to take the square root. And I'm going to do that to both sides. So now the square root of x plus 2 equals y. Just so you know, if I had a little quick graph, my original x squared minus 2 would have looked something like this. And now my square root of x plus 2 is going to look something like this. So they're not exactly, right? The full graph is not exactly the inverse. That's why we would restrict it to maybe just everything that's positive. So that way this part of the graph would be the inverse of that part of the graph. All right, but for right now, we're just focusing on finding it, and that's okay. So for the last one, I want you to try to find the inverse of f of x equals x cubed. Pause when you're trying and unpause when you're done. So our answer would be y equals the cube root of x. All right, and that's it for this lesson.